Mechanum's virtual coding class for Java in FTC. So today is our computer vision tutorial class, and we're going to be talking about the Huff circle transform, which is an OpenCV method that allows you to detect circles. And we're loaded on Eclipse today because it's just easier for me to load files into it and display the algorithm running in my actual computer. And we're going to be looking at the how we use this for the 2023 to 2024 game. And for us, our algorithm was 100% consistent, even when we went to the World Championships across and state, league, all our meets across a variety of different lighting conditions, and we didn't really have to change anything to tune it to different lighting conditions either at each of our events. So starting off, I'll show you how it kind of works. But it gives you a ton of candidate circles, and some of these, as you can see, aren't really circles. But then it gives you some of the circles you'll be able to tell have a higher concentration of red pixels in it, which is what we use to detect where our circular looking team element was. So now let's pop on over to the code and I'll show you guys how to do this. So we're going to need OpenCV, and to do that we are going to go to our GitHub. So this is my personal repository for that, and it has a ton of information about how to use easy OpenCV and installing it on your Android Studio and actually running it in your code. So once you do that, you are going to need to make a pipeline, and this is going to look a little bit different than the Eclipse code, because in Eclipse code it's not for the robot, it's just to run it in my laptop. So keep in mind that you will need to make a pipeline, and you will need to follow the steps to run this code in your actual program. Alright, let's take a look at the code. So this up here is just initialization code for me to randomize files. Hopefully it gives me a different one this time. Yep. So the first thing we're going to need to do is initialize two matrices. And matrices are 2D arrays of color vectors that hold information about your image. So we use this mread function to turn the file into an OpenCV matrix. And then we're going to take our source matrix and convert it from blue, green, red, which is the color space it's in now, to a grayscale. And that's going to help our canny edge detector, because it runs a convolution over it to detect where the edges are, and that requires grayscale. And now we blur it just to help with our image processing accuracy. Alright, now we make a new empty mat called circles, or you can name it whatever. But then we run this imageproc.huffcircles method, which has a lot of arguments in here. So the first one is your source matrix. Your second one is your end matrix, where the circles are going to be put into. Your next one's your detection method. Currently, this is the only one available on OpenCV, so you have to use imageproc.huffgradient. Then this is your inverse resolution ratio, which I always keep at 1. And then the next one's pretty important, minimum distance between the centers of each circle. And for this one, you're definitely going to need to play around with, because you don't want to have too many circles, because that makes this algorithm kind of too computationally heavy on your robot. But also sometimes when you have a few circles, it won't detect your object as one of them. And this algorithm is going to be like a 3-step thing. So it has Huff circles, it has color thresholding, and position boundaries in there. So the next one is our canny edge detector threshold. So our algorithm is going to go around and it's going to apply convolution to find edges, and run this canny edge detector algorithm. So play around with this threshold, and then also the threshold for center detection as well. And then your next two are pretty important as well, minimum radius and maximum radius. Uh, for me, I like to keep size, like tolerance, pretty big because you never place your robot in the same spot every single time. So, which is important. Here's some of my just drawing on the screen setup, visual setup here. But once we have all those circles in our circle matrix, I run a for loop, and for each circle, I get the area of each circle and then also some coordinates for a box around that, just using the sign and everything. So top left, bottom right coordinate, and then the area you use finding the radius and just squaring that. And we draw a circle here, and then for each circle we have or for each rectangle, I'll say, we use a double for loop, and we go through each pixel in every rectangle for each circle. Sorry, gets a little confusing, but basically we're just going through the circle and finding out if there is a red pixel or not. And then if there is, then we're adding to our accumulator. And then after we're done with that, then we find our fraction of red by getting this accumulator value, so the amount of pixels that we deem are red, and dividing it by the area of the circle. And then if this fraction of red is above a certain threshold, so for us 30% of the pixels in the circle are red, then we know that it is our circle. That is a 1, and then we chose that. So here we draw a black circle around our ball. And it is a pretty foolproof method. I will say though, in our final version of code for worlds, that we don't use the RGB color space. We use hue saturation HSV, which is hue saturation value. Sorry, and we use that because it's harder to find like false blues and false reds in there. This method can probably be used in any game. It just depends on what the game rules allow for your team shipping or your team prop or whatever it is. There's always usually a 3D printed element that your robot has to find on the field some way or another. Now, the reason why we chose to do this instead of using contours, if you're familiar with OpenCV or like TensorFlow or something, was because, well, first of all, I didn't really want to set up a TensorFlow model and do all of that. So this was like programmatically way quicker for me to figure out. That plays a huge role in when you're developing things. And then instead of using contours, we use Huff Circle Transform because these tape lines are essentially the same color as the ball, which makes it really hard using contours to decipher a ball from a tape line. So if we use a circle, then we can actually differentiate those two. So yeah, that is the Huff Circle Transform, and if you want more information on that, make sure to take a look at the 4-screen FTC Vision wiki, where it will be uploaded.